Good day, welcome to One-on-One Maths Private Tutors. Today we are going to look at solutions to the set exercise, the final set exercise from past exam papers that we gave you. Let's look at number 1A. On the Venn diagram, shade the region represented by B bar intersection A. So understand the meaning of intersection. When two roads meet, this is the intersection. So we want a common place, a place that is on this road and on that road. That's what we call an intersection. Same applies to sets. When we say intersection, we want to see the common area. So we want B bar. What is B bar in common with A? First, we have to look for B bar. B bar is everything outside B. So this is B bar. Intersection A. What is A? Let's use green there to shade A. Everything inside A, including B. Now, when we say intersection, where are they meeting now? Where is B bar in red meeting A in green? So we can see that B bar intersection A is all of A excluding B. So we have A, B. So this should be our B bar. Okay, and when you are shading, put lines. Don't, I see most of you are making a mistake of trying to paint this whole picture. No, just lines will do it. Okay, we can clearly see that this is excluded and that is excluded from our shading. So intersection, make sure you understand intersection is where the two meet. Our green is meeting red only in this region. Let's go to B. Here is some information about 100 people who visit a cafe. 32 drink coffee, C. 40 drink tea, 50 eat pastry, 18 drink coffee and eat pastry, 21 drink tea and eat pastry. Complete the Venn diagram. We do it from inside going out. These intersections are what we would want to fill in mostly. 18 drink coffee and eat pastry. So coffee and pastry, 18. 21 drink tea and eat pastry, so 21. 32 drink coffee. So all in here in C, the sum is 32 here in C. So 32 minus 18, 14. So if we say 18 plus 14, we'll get 32, right? So coffee is covered. 40 drink tea. So we can have people drinking tea is this set. Never mind that they had pastry. So 40 minus 21, 19. So 19 in here. 19 plus 21 will give us 40. So we have all the people who drank tea as 40. 50 eat a pastry. So the whole total here is 50. So if we say 50 minus 21 plus 18, this will give us 11. So 11 people here. Now let's add, because some people may get into the restaurant and do nothing. They should be out here. 19 plus 21 plus 11 plus 18 plus 14. We get 83. But we are told 100 people visit a cafe. So 100 minus 83, which will give us 17. So 17 people did not drink tea or eat a pastry or drink coffee. Okay, so that is how our Venn diagram will look like. So take care to start from inside going out. It's usually easier to build your Venn diagram that way. Union. What is the difference between union and intersection? Union, batanidzwa. So you're combining everything. Intersection is common areas. So if you have two sets like that, A and B, and you say A, intersection B. A, intersection B is this. Why do we say that? Because A is this. This is, all this is A. And B, we can use red there. This is B. Okay. So when we say intersection, where are they meeting? We can see red and green common in here. So our intersection will be this area. Now, when we say A union B, we are now saying combine A. If this is A and B, this is B. So we are combining everything. So in the end, we just have one set like that, touching everything, including the intersection. So we are saying A union B is everything in A plus everything in B. Find the number of elements in T union P union C. T union P union C is the adding everything that is in here. So that's where we start. T union P union C will be 19 plus 21 plus 11 plus 18 plus 14, which we have found to be 83. So we have 83 there, but we want the complement now. Anything outside this, which is 17. So we have 17 there. Let's go to number 2. Use set notation to describe the shaded region in the Venn diagram. Again, union, intersection, and complement should be known. So we have, this is almost, so we can start with P, union R, but we don't want anything that is of Q in that set. So we are saying anything that is of Q in that set should be removed. We have said B union R is what we start with. So it should intersect with anything that is outside Q, Q complement. So what are we saying? We are saying we are starting with P union R. Now we don't want anything that is Q. Outside Q is this. So now we only want the intersection, which is this region there, where the green and the red is intersecting, or where the green and the red is meeting. This will be the set that we want. We said P union Q, then intersection of Q complement. Let's go to B. Universal set is X such that X is a positive number. So we say in set builder notation, the universal set is defined by X such that X is a positive number. A is defined by X such that X is greater than 9 but less than 10. B is defined by X such that X is an irrational number. Write down an element of A, intersection B. So we want an irrational number that is between 9 and 10. Okay, on our video of numbers, the very first video that we did on numbers, we know how to get irrational numbers between two integers. What do we say? We say 9 squared is equal to 81. 110 squared is equal to 100. Now, between perfect squares, any square root will give you an irrational number. So we have root 82, root 83, root. So A intersection B is equal to this set of root 82, root 83, root 84, on and on until root of 99. So we can pick any of these. So I'll just pick the square root of 85. Now let's go on to the next one. The universal set is 0, 1, 2, 3, 4, 5, 6. P is 0, 1, 2. Q is defined by Y, which is 0, 2. P is defined by X, which is 0, 1, 2. List the members of P intersection Q. So if we had a Venn diagram, which members will be common? This is our universal set. This is our P. This is our Q. We have 0 and 2 common. Then we have 1 in P. So in fact, since this is an empty set, we can see Q is a subset of P. So we can say P, Q, 0, 2, 1. List the members of P intersection Q. What does P and Q have in common? 0 and 2. Find number of elements of P bar union Q. Number of elements in P bar. So we have our set. Let's see how we can shade it, our Venn diagram. P, Q. So we're saying P bar, anything outside P, union Q. Q is there. So if we combine the two, we have to bear in mind that the universal set is 3, 4, 5, 6. So 3, 4, 5, 6 out there. So P bar out here, union means combined with Q. So we are saying what's in here in Q, combine it with what's outside there. We want the number of elements. So we have 1, 2, 3, 4, 5, 6. 6 is our answer. Now we go to C. R is equal to Z such that Z is equal to 2x plus Y, where X is an element of P, Y is an element of Q. List the members of R. We know R, we simplify it to 2x plus 1. X is an element of P. So what are the possible X values? X can take these values 0, 1, 2. And Y can take these values since Y is an element of Q, 0, 2. Now, when X is 0 and Y is 0, we have our Z being equal to 2 times 0 plus 0, which will give us 0. When X is 0, Y is 2. Z is equal to 2 times 0 plus 2, which is 2. Now we have, when X is equal to 1 and Y is equal to 0, Z is equal to 2 times 1 plus 0, which is 2. When X is equal to 1 and Y is equal to 2, Z is equal to 2 times 1 plus 2, which is 4. Now we go on to X being equal to 2. When X is equal to 2 and Y is 0, Z is equal to 2 times 2 plus 0, which will give us 4. When X is equal to 2, when X is equal to 2 and Y is equal to 2, we have Z being equal to 2 times 2 plus 2, which will give us 6. So members of a set are only nominated once. If we have double entries like this, we just take them once. List the members of R. These are all the members of R. So we have 0, 2, 4, and 6. So each member of R is represented by Z, such that Z is equal to 2x plus 1, where we get our X values, we get them from P, these are the members of P, and our Y values, we get them from Q. So by combining them, we will be able to work out the values of Z and then list them. In the Venn diagram, shade the region represented by A intersection B complement. Let's use red for A. This all is A. A intersection B complement. B complement is anything outside B. So let's use blue here. Anything outside B. Okay, now we have that. Where is the intersection? Intersection means where they meet. Where does red meet blue? You can see is this our new diagram here. A intersection B complement is this area there. Now we want B intersection C complement. So this is our A intersection B complement. Now we want B intersection C complement. So we have A, B, C. So we want B first, the whole of B, and then C complement, everything outside C. Where does B meet C complement? Where is the intersection? This is the intersection. So we can say redraw and reconstruct A, B, C. So that is B intersection C complement. Now to join it up, this and that, what would we have when we combine these two? Because we are saying that and that, the union. How do we unite those two? So A, B, C. So to unite them, let's start with this. Then we combine with that. That's how we combine this and that. Okay. Now we have our A intersection B complement union B intersection C complement. So we start with this set, then go to that and find how we can unite them. All right, so that is our solution. So back on our diagram, we could then with that part, combine it there. So that's our solution. And the making is there. Now we go to the next question. One morning, 50 people visit a library. 35 of them borrow a book. 12 of them use a computer. 8 of them do not borrow a book and do not use a computer. Using a Venn diagram or otherwise, find the number of people who use a computer but do not borrow a book. It's easier to work with our Venn diagram. What are we told? The total should be 50. When we add our universal set, we should have 50. And we have some who borrowed a book, we can call it B. Some using a computer, we can say C, because there could be an intersection because people can borrow a book and use a computer when they visit the library. 8 of them do not borrow a book and do not use a computer, so we have 8 outside there. 12 of them use a computer. Okay, so we want to see how many either borrowed a book or used a computer. So we can say 50 minus 8, then we get 42. So we have 42 in this set. If we say X amount of people used a computer and borrowed a book, so what would we have here out there? 35 borrowed a book. So 35 is book is there. So 35 minus X are the ones who just borrowed a book and did not use a computer. 12 of them use a computer. 12 of them use a computer. So 12 minus X are the ones who just use a computer but did not borrow a book. Okay. So what do we have here? If we add these up, we should get 42. Everyone in here is 42. So if we say 35 minus X plus 12 minus X. So if we have this 35 minus X, which are those ones, plus X is X, plus 12 minus X is equal to 42. Then we can get the value of this center, this intersection here. So we can have 35 minus X plus 12 minus X is equal to 42. Minus X plus X, this cancels out. 35 plus 12 is 47. Minus X is equal to 42. We can take this X to that side and 42 to the left side. So we have 47 minus 42 is equal to X. X is equal to 5. So now we can draw our Venn diagram with real values. So for whenever we see X, we put 5. So we have 5 there. 12 minus X, 12 minus 5 is 7. So we can put 7 in here. 35 minus 5 is 30. So we can put 30 in here. So now, if we add all these, they should give us a total of 50 people. 30 plus 5 plus 7 plus 8 will give us 50. Using a Venn diagram, or otherwise find the number of people who use a computer but do not borrow a book. So people who just use a computer are 7. Now let's go to number 5. In the Venn diagram, shade the region represented by A intersection B. A is this region, B is this region. So where do they meet? This region. So our answer will be, this is our A intersection B. This Venn diagram shows information about the number of students who study English, Spanish, and German. Find the number of students who study English and German, but not Spanish. English and German, that is an intersection, but not Spanish. That is a complement. So we want English, intersection Germany, intersection not Spanish. So English and German is this whole set. Not Spanish is anything outside here. So that is the intersection. Not Spanish is everything outside Spanish. The number is 5. Find the number in German. G union S complement. G is all this. Union, combining, batanism. Now S, the complement, anything outside that. So it's this and that. 11 plus 4, 15. So our answer is 15. Thank you.